Here we're going through 3 questions that have been causing some problems for a few people on probability. This first one is given as a tree diagram question, and I will do it with the tree diagram, but you can see maybe as we get through the method that a tree diagram isn't the only way you could answer this question. The first problem with using a tree diagram here is that somebody's taking some coins out of a bag and she takes out exactly 3 coins. That means the tree diagram is going to be quite a large diagram. So I'll start off by drawing that, but I'm actually not going to fill it in completely, partly due to not having enough space on this whiteboard, partly due to laziness, and partly due to showing you that not every single calculation is essential, especially when there's quite a lot to do. So she's got 3 choices of coins, and there's 2 different types of coins in the bag. So that means that when she goes in the first time, she's got 2 options. She can have 50p, which I'll just put as 50, or a pound, which I'll just put as 1. That's her first choice. Now she goes back in for another choice. That means that if she took a 50p initially, she can go back and get another one of those, or she'd get a pound. But she might have taken a pound. That means there's 2 branches here as well, a 50 and a 1. She's going back again for a third time, so we have to put another 2 branches off each of these 4 extensions. So she could go 50-50, and then she could have 50 and a pound there. She'd go 50, a pound, and then again, those 2 options. She could have gone pound, 50, and then those 2, and then finally she would have gone pound, and then you get those. So you can see it's quite a large tree diagram. I'm barely fitting that in there. If there was another choice, it would become quite unmanageable. So tree diagrams aren't always the best tool to use. That's that there. I'm not going to put all the probabilities on there because it will make it look quite messy, and it would actually need to have them all. But let's have a look and see which combinations we might want to use. Here's where a tree diagram is quite useful. So she's trying to make £2.50 from these 3 coins. So 50-50-50, no. 50-51, no. 51-50, no. 51-1, yes. So I'm going to put a little star there because this route here is going to get us £2.50. 1-50-50, no. 1-51, yes. 1-1-50, yes. 1-1-1, no. So those are the 3 ways she can make £2.50. So I'm just going to work those ones out. I'll put these on a separate board here. So the probability of getting, the first one was 50 and then 1 and then 1. I also want to know the probability of getting, it was 1 and then 50 and then 1. And then lastly, the probability of getting 1, 1 and 50. So I mentioned earlier that you might not have needed the diagram. I mean, you can see that there's only really one way of getting £2.50 from 3 coins like this, £2 and a 50p. But there are 3 ways you could draw them out of the bag. The order they come in would be different events. So you've got to work these out separately and then add those together at the end. So if we just put those ones on here, so we're going to go down this route here. So 50p initially, going back to the question, there's 8 coins in the bag, 3 are £1 coins and 5 are 50p coins. So the chance of getting the 50p is 5 out of 8. But if she's taken one of those 50s, when she goes for the pound, it's going to be 3, but out of 7 now. And then go for the pound again, well, she's taken a pound and a 50p out now. So there's only going to be 2 of the pounds left and 6 coins in total. So when we're trying to work out the chance of this, this and this, this and this and this, we multiply those together. So my calculation is going to be 5/8 multiplied by 3/7 multiplied by 2/6, and I'll work this out in a second. Next one is £1, 50 and 1. So the chance of getting a pound initially is 3 out of 8. If she's taken a pound out, getting a 50 next is going to be 5 out of 7. And then going back for another pound there is going to be 2 out of 6. So I'll put these in. 3/8 multiplied by 5/7 multiplied by 2/6. You might have already started to spot a pattern with these numbers, which will become even more obvious now. Okay, so £1, £1.50, so £1 we've already got that 3/8. Getting a pound again at this stage would be 2/7, and then getting the 50p there, 5 out of 6. Okay, so that's going to be 3/8 multiplied by 2/7 multiplied by 5/6. So these calculations all have something in common. The denominators are exactly the same for each of these, 876, 876, 876, which does make sense because you're choosing out of 8 coins initially, and then you're choosing out of 7, then out of 6. And what you're choosing is actually the same as well, just in a different order, 532, 352, 325. And when you multiply fractions, you just multiply the top and then you multiply the bottom separately. So you're going to get the same answer for all of these three things. So if we just do that quickly on the calculator, 5 times 3 times 2, well, actually that one I don't really need to do on the calculator, but I will to check anyway. So that's going to be 30. That's going to be my numerator for each one of these. Denominator is going to be the same as well, 8 times 7 times 6. It is 336. Now here's one where you should not be simplifying at this stage, because now if we're adding these three together, because this, or this, or this, it's all good, we'll add them all together. Clearly we're going to get 90 over 336. You can simplify that from there, but actually in this particular question it didn't ask you to, so if you type that into MathsWatch, it'll get you the correct answer, and the simplified version as well. Okay, that's that question. This one here is potentially a tree diagram question, but as I said, I'm going to show how this can be worked out without using a tree diagram and just using the and the or rule. So we've got the extra complication here of the fact that we don't actually know how many counters are in the bag, but that doesn't mean we can't do the same sort of maths. It contains n counters, 1 is yellow, the rest are green. So the first thing I thought of doing was writing out what the probability of choosing a yellow would be. Well, there's 1 yellow out of n counters, so it's this. Chance of choosing the green is a little bit less obvious. It's still out of n, but how many green are there? Well, 1 is yellow, the rest are green. So the number of green is the total take away the 1 yellow. So it's this. And it's a little bit intimidating to see that, but that is the simplest way you can put it. The number of green is 1 less than the total out of the total. So once you've got these, you just do the same thing that you would do if you had normal fractions. So it says express in terms of n, so we're going to be keeping this n, there's not going to be an actual answer here. The probability that both counters are green, right? So that means green and green. So I'll write that out as GG. And the probability to get a green, well, we've got that already, so that's going to be that. But it doesn't say she's putting the counter, or say she, doesn't actually say what gender this person is. This person is not putting the counter back in the bag, so they've got 2 counters. 2 counters are taken at random. That means they're holding 2 counters. That means they didn't put one back. So we've got to think about that when we do our next probability. So going back for another green, well, it's going to have n minus 1 counters left in the bag because one of them has been taken out. We've also lost 1 green. And what happens if you take 1 away from this? N minus 1, subtract another 1. Well, it's going to be n minus 2. I mean, you could write n minus 1 minus 1, but that's going to simplify to this. And because we're using the and rule, we're saying this and this, we multiply those two together. Now, that looks like quite a tricky thing to do, but here's a little trick that you haven't been shown yet. So this question snuck in there a little bit ahead of time, but there's no harm in seeing it now. All of these terms really are in brackets. That big division line there, it means a bracket. Once you see that, you can see that we've got an n minus 1 on the top here, and an n minus 1 on the bottom here. And because these fractions are going to mix together when they multiply, you can cancel stuff out from the top and from the bottom, even if they're on different fractions initially. Like for example, if we use some numbers here just to show this more clearly, if we have like 5 over 7 times, let's say, 3 over 5, well, if we work it out properly, we get 15 over 35, and that's going to be, if you divide that, it's going to be by 5, that's going to be 3 over 7. Okay, but what if I just cancelled out the 5s? It's just 3 over 7. You can do the same thing with the algebra. So if we cancel out the n minus 1s, we get just the n minus 2 on the top over n. And that's the answer to you. If you type that in to MathWatch, that will give you the answer. You have to use the bracket and then the slash key to actually do that. The next question says, the probability that both counters are green is 0.9. How many green counters in the bag? Well, we know what the expression for this is. This is the probability of getting 2 green counters, and we now know that that is equal to 0.9. So 0.9 equals n minus 2 over n. It's an equation to solve. We don't really want this fraction here, so if I can multiply both sides of this by n, we get 0.9 n equals n minus 2. Let's go on to this page here. If I subtract 0.9n from both sides, I'll get nothing on that side, and I'll get 0.1n there, minus 2. And then if I add 2 to both sides, I get this. And if I then divide both sides by 0.1, or times by 10, I get that. N is 20. Now it said how many green counters are in the bag. Well, n was the total, wasn't it? And there was 1 yellow in there. So the green must equal 19. That's it. The last question. Now this question, I have to admit, was not actually possible with the maths you've seen so far. So don't worry if you didn't get this. It's something we're actually going to go on to very soon. And you've seen part of it, but there's one step that you just haven't seen yet. So you can see it now. Venn diagram, pretty straightforward in theory, cats and dogs. It says there's 40 students in total on the whole Venn diagram. We then have to work out if somebody is chosen who does own a cat, what's the probability they own a dog? Normally it wouldn't be too hard. You would look in the cat circle because they definitely do own a cat. So you're not supposed to be looking anywhere else. It's just out of these people here. And you say, well, how many of these people own a dog? Well, these 7 do, so it'd be 7 out of this total. But what is that total? Because we don't actually know what x is. And that's where the difficulty comes in. So you solve that by doing this. You'd add all of this stuff together and make it equal to 40. So I'm going to quickly expand this bracket here, this x, and then bracket x plus 3. So I'm going to get x squared plus 3x, that's where that's come from. It's going to add all the rest of it up, 7 plus 4x plus 3x minus 6, and all that is equal to 40. That's the total number of students in the diagram. Let's do some simplification here. Can't do anything with this x squared, but we've got 10 x's. And we've got 1. That equals 40. Right, now this equation is a quadratic equation. Any equation that has an x squared, or a y squared, or a b squared, any letter squared, plus one of those letters and a number in front, so no power, plus just a number equal to 0, that's a quadratic equation. Now we can make it equal to 0 by subtracting 40 from both sides. But you have to recognise that it has got this potential format. Now there's loads of ways to solve these equations. These are probably the most common equations in maths, and we haven't really looked at how to solve them, but you've actually seen some of the steps involved. So I'll show you the way that will be most familiar. you can put this into a double bracket. Now, we've done a lot of that. Factorising that into a double bracket requires an x in the front of both, two numbers that multiply to make 39 but add up to make 10. Go through some trial, or negative 39 I should say. Go through some trial and error, and you'll see that it's going to be, well, 13 and 3, and it's meant to add up to positive 10, so it's going to be positive 13 and negative 3. Now we're actually trying to solve the equation here, trying to work out what x is. These two brackets are being multiplied together. These are two numbers really, we just don't know what they are. If you want to make 0 as your answer from multiplication, at least one of the numbers has to be 0. There's no other way to do it. So if this bracket here was a 0, what would the x have to be? Well, there would have to be negative 13. That would give you a 0 bracket, and therefore the overall calculation would be 0. But maybe this x could give us the 0. So that x would have to be 3. Both of these answers are correct. It has two solutions. That's because it's a two-dimensional equation. Okay, but actually in reality, if we go back to our Venn diagram, if x was negative 13, that would imply that there is negative 13 times 4 people who have a dog, and that doesn't really make sense. You can't have negative people, so it must be the 3 that is the real answer we want. So we go back onto the actual Venn diagram now. We can put these values in and now work it out. So if I just do another sketch here, I think probably the best idea of the same thing, but now with the actual numbers in. So x is 3, so 7 is still in the middle. Okay, so 4 times 3, so there's 12 people there. 3 times 3 is 9 minus 6, so there's only going to be 3 on the outside there. And then over here, well, the best way to do it probably is to do the bracket first. 2 plus 3 is 6, times 3 is 18. Probably just good to double check and see that those all do actually add up to 40, because if they don't, then you've gone wrong somewhere, but luckily they do. Now we can answer the question. A student is chosen at random, they own a cat, so I should label this actually. So they're in the cat circle, so you're only allowed to look inside this circle now. Nothing outside the circle is available. So what's the probability of somebody here in this circle owning a dog? Well, it's 7 out of, I'm going to add these two together, out of 25. And that is the chance for that question there. Okay, so that should be some valuable suggestions. Please do ask if you have any other questions about anything else you're not sure about, and good luck with the rest of the work.